Time period of a compound pendulum. Compound pendulum, I have shown 3-4 diagram. One is the rigid body, another is the compound pendulum, this is the disc, this is the ring. Okay. First of all of you should know what is the difference between simple pendulum and compound pendulum. In the simple pendulum, we all have seen that time period depends only on the length, does not depend on the mass. But in compound pendulum, mass and distribution of the mass also play the role in the time period. So I hope the difference is clear to all of you. Now, I have taken one example here of any one rigid body. Suppose you displace the rigid body towards any side, and this is the center of mass of the rigid body, and this center of mass shift towards like this, and let I say this angle is given you theta, and you will say here the weight is acting in the downward direction, that is mg. This mg is the component, this component is known as a mg sin theta, and this component is known as a mg cos theta. Now for the restoring force, mg sin theta is responsible, or we can say for the restoring torque, if we calculate what is the restoring torque in this situation, we will say mg sin theta into this distance L. So restoring torque is given by minus mg sin theta into distance from the axis of rotation, that is L. And when theta is small, sin theta can be written as theta, so torque is given by minus mg L into theta. We know torque is given by I alpha equal to minus mg L into theta, and alpha can be written as minus mg L upon I into theta. We know the standard equation, alpha equal to minus omega square theta, so omega will be root mg L upon I, and if you calculate the time period, that is 2 pi by omega, or you can say 2 pi root I upon mg L. This is the time period of compound pendulum. Sometimes we require this formula. Of course you have to learn this formula. Sometimes this formula can be shifted in another form, that is the radius of gyration k and distance between the point of suspension and center of mass. How will you calculate it? Dekho. I is the moment of inertia. It can be written by the parallel axis theorem, ICM plus ML square. Okay. What is ICM? ICM can be written as the MK square in terms of the radius of gyration plus ML square. So when we put the value of the I in this equation, we get another format, T equal to 2 pi root K square upon L plus L upon G. So this is the another form of time period of compound pendulum.